In this video, we're going to take a look at how parallel lines within a triangle can cut the segments of that triangle into different proportions. So the only way to really see what I'm talking about is actually to see how it works. So let's say we have an example, a triangle here, and within that triangle we have a parallel line. So as you can see, that line that we just drew is parallel to that line. Alright, let's label our triangle so we can talk about it. So we have A, B, C, D, and E. Okay, according to the triangle proportionality theorem, this parallel line will chop these two segments up into a way that is proportional. So what do I mean? I mean that if these two lines are parallel, then AB over BC, notice all I did was write the two parts here, this part over this part, will be equivalent to this part over this part. So equivalent to AE over ED. And this only works once again because this line that we inserted, that's chopping our parts up, is parallel to this line. We could go ahead and do a different parallel line and the same thing would happen. So let's call this one HIJ KL. So now it's parallel to the bottom, which means that, okay, our parts, as you can see, that's one part and that's one part on the left. So HL over LK is going to be equivalent to this over this. HI over IJ. So all these parallel lines do is chop or triangle segments into proportional parts. Alright, so let's take a look at an example. Okay, so here we have a triangle, and within our triangle we have a line that is parallel to one of the sides. That means that that parallel line is going to chop our triangles into proportional segments. So we have here that 7.5 over 3 is going to be equal to, we don't know what that is, so we can continue to call it PS, it's the thing we're trying to find, over 2.5. Now we can go ahead and cross multiply, and on the left side we get that 7.5 times 2.5 is equal to 3 times PS. Alright, so when you multiply 7.5 by 2.5, you get 18.75, which is equal to 3 times PS. Now we want to isolate that unknown, so we can go ahead and divide both sides by 3, so we can get rid of that, and we get that our side PS is equal to 6.25. Alright, and that's how the triangle proportionality theorem works. Now in addition, it also works backwards. So for example, if you were given this side, but you weren't told that these two lines were parallel, you could test to see if the two pairs are proportional, and if they are proportional, then you could prove that this line is parallel to this line. So that's just a different way you could play with a question like this. Alright.